Our next speaker comes to us from the University of Nebraska, Lincoln. Benny Mote actually did his bachelor's degree at Nebraska, Lincoln, and then followed it up with a PhD at Iowa State University. Following that, he actually came up to spend some time with us in Canada, and a few of us got to know him there, where he was the molecular geneticist at Fast Genetics until he came back to Nebraska Lincoln, and is now an associate professor, where his research is focused on genetic and management improvement of swine production, generally utilizing precision technologies. So with that, I'll pass it over to Benny and to give us some perspectives on the work that he's been doing.
I appreciate being offered the opportunity to come up and tell you a little bit about the research that I'm doing. I will also say, when we get into some of the precision livestock farming, I rely heavily on some teamwork with engineers, and this is coming out of a conference in Austria for the Precision Livestock Farming Conference. It was definitely noted that we need engineers and animal scientists to work together. If you look at a lot of the models that they had there, they were really great, really awesome, but they're on 10 animals. So we definitely need the two to come together to make something neat and actually usable at the farm level. And so we have some things we're working towards there at the University of Nebraska, and I'm just part of a team. I guess I'm the one, I'll say I know the animals, and then I'm trying to learn some of the engineering here as we go. Something that's always been a little bit near and dear to my heart is the sow longevity. Growing up around animals and selection, was livestock judging teams, 4-H FFA, University of Nebraska, and it was always drilled into us the role of feet and leg structure for sow longevity. And I look at that as always the basics. If you don't have that, the rest of the bells and whistles on the sow doesn't matter. So sow longevity plays that vital role in the sow being able to stay on that farm and be profitable. Depends on who you want to look at. Sows need to produce 3 litters before they pay for their investment costs. The voluntary sow mortality rate that we have going on right now and the replacement rates are much higher than ideal. I think they're higher than what a lot of us on the farming side would like to look at. And then if we have to explain that on the social side, to those that are not in our industry, we have a very hard time of explaining those to why we're having 15% sow mortality. We're replacing 50 or 60% on the sows annually. We have a really hard time doing that today, and I think we're only going to get more pressure on that going forward. Today's corn and soybean meal prices keep adding to the cost of what those replacement females cost to get to that point. If you want to throw in the buzzword of sustainability, what it costs on the environmental side to produce that animal, we need to try to keep those animals around longer to recoup that. And then if we look into where the industry is going, either voluntary or potentially forced or maybe incentivized with a little bit of carrot up front and a stick in the back, with the Prop 12 and some of the other national mandates of going towards gestational group sow housing, we need to think that most of the sows that are being selected today, especially here in North America, we're several decades out of where they've been selected and grown in, or selected in crate environments, especially on the longevity side. So we really haven't even tried to maximize that or even know where that's at when we look at these sows in group sow housing. And then it's nothing, it's not news to anybody here, but finding labor, especially quality labor, to actually come in and make these selections is, I'm going to say, virtually non-existent in a lot of places. So if we can take a little bit of the art and combine it with the science of some of the technologies, hopefully this will help us move further to be just a little bit better, to do a little bit better job on gilt selection and help answer some of these questions that society is going to start pushing towards us. So since there's pictures of me floating around where I was knee-high to a grasshopper, as they say, around pigs. I've looked at hundreds of thousands of pigs in my life. We always have these ideals of what perfect is. Well, perfect goes out the window when your boss tells you to go into a barn and you need to set several thousand gilts to go to a customer. And when you do that, you have ideal in mind, but really what you need to have in the back of your mind is, what combination of these traits are going to get that animal to parity 3 and hopefully beyond. There's some new metrics coming in out of Europe where for them to sell into certain markets on the milk side, they have to have prove that they're a herd, they don't cull anything on average before their 5th lactation on the south side, on the cow side. So if some of that stuff comes over on the pig side and we're culling our sows before parity 3, where are we going to set those levels? So just something to think about of what they're seeing and what they're doing, and then what might be coming over here. And so we have a lot of little different things that we're really trying to select for. You know, the front legs are really key. 60% of the weight of a pig is up on its front legs. It does shift a little bit towards the rear when those sows are heavy bred, late gestation. I think there's a lot of gilts you'll go through selection, they're okay, and then you see them heavy bred right before they go into the fairing crate, and then you start to get some of those gilts that splay out. So they were probably okay on the rear legs going in, but when you add that extra weight of that extra litter that they're carrying, then it becomes too far for her. So we have lots of intermediates, lots of good. Definitely we have some bad, some things that are too far under. But what is ideal, what is acceptable, and what's going to get us to those sows that last a parity 3? And then also we had another big question of how do they change? I remember when I was at FAST, we would get customers talk about when those sows come in, the gilts come in, they're acceptable. But after a couple of years or a couple of parities, they get a little softer on their pasture and they get a little weaker in their hocks and they're starting to splay out. So we really need to try to identify what changes in those animals, what do we need to look for at selection age or before that's going to help us get to that point. So I'm going to go through several different studies that we've done. So one of them, you know, it's not commercial scale. We have a smaller farm. I would love to push for a bigger farm, but most universities kind of have small farms these days. We had 5 different groups, 507 of a York by Landrace cross gilts. We recorded, we videoed data at up to 16 time points. We started at roughly day 112 of life out in gilt development, and we went all the way out through parity 4 if the sows actually stayed that long in the herd. Gilts were only removed for severe lameness, welfare, failure to breed, or return to estrus. So not necessarily commercial standards, but we still had some standards in place. And then we also had 4 of those groups where we looked at the difference in their first gestation, because that's we just had space for that, the difference between pens and stalls. So we were able to add that to it as well. The sows would come up, we would record them with essentially a GoPro type camera, pull the video off, and then we come back to analyze the video with some still images. So a multitude of traits were pulled. So from the side view, you can tell we can get a host of points. So we can, because it's relatively easy, we can get a lot of our body metrics, so body length, depth at the shoulder, depth at the flank. We also get rump slope, which is also, I think, kind of an indicator of fatness. It shows up significant in a couple of times, and I think it's more probably related to the animal being fat than necessarily the angle. But there is potentially some case with that of a cleaning out if you look at that and maybe some of the other species in literature postpartum. And then we have some of the angles for front knee angle, pastern angle, front and rear. Not shown here, but we also had a camera sitting up front. And then we had another camera that we would slide underneath so that way we can catch whether or not the animals are towed in or towed out. We tried to start with the camera behind, but for some reason it's one of those traits where when you look at it on film, it just does not match what I perceived with my eye. But when we go to putting it under, especially with these the tracks underneath, it is really easy to get a very objective measure of whether or not an animal is towed in or towed out. And so you can kind of see a line of where kind of time came in and we started adding new traits. So there was this ongoing sow longevity project that was taking place. I was looking to try to add value to that. So you can see kind of where the time frame kind of came in and where we really started doing all the measurements on it. And then we also, we added in a Zenpro sow chute, and we started lifting those sows to look at the foot integrity as well. And so you can tell when you look at 507 animals that started, we have a massive amount of data points when you kind of come in and take a look at all the data and knowing what you need on every angle. So just some of the big observations that we initially took out of that. Body size and foot directional positions were reliable between evaluators. So initially this is a human going in using Image J to pull out the actual feet and leg angles, body measurements. We're working towards the automation, but we needed to have a ground truth in here. Leg and body angles were reliable if you had the same measure repeated. And so they're definitely within themselves. And then the more we can do to remove subjectivity is going to just help improve the data and make everything cleaner. And one thing that I noticed with one of the grad students that we had working, she's 5'2" on a good day. She's wearing really tall shoes, and I had another student that was 6'6" if he's slouching. When those two people look at the same animal, if they're standing, you wouldn't think it's going to be that much of a difference in the view of the animal, but if we look at it when we were setting cameras, you really need to think of where you're positioning cameras to pick up the angle that you want to measure, so that way you're going to get a consistent view each and every time. So we did do a few things as we learned. So initially we had one camera. It was actually a little bit lower than this, but it was centered on the body, and we tried to get our front leg traits, our rear leg traits, body lengths all off of one view. We actually moved later towards positioning one camera to just catch the front legs, one camera just for the back, and then one that was set back further to capture the full body. We were getting much more reliable numbers when we had our cameras set up to do so. So one of the first things that we did outside of proving that those were reliable is we actually calculated the heritabilities on those traits. So the body traits, a lot of people have looked at those. They were still heritable. We were seeing the same thing, so it's good our data was matching that. But then we also looked at the knee angle, hock angle, the front and rear pasterns, rear slope, and then being able to pick up the toe in, toe out, which is something that really nobody else has necessarily looked at to that level. So it's nice to see that they're heritable. And so the way this would be a front leg, it'd just be one of the feet. We kind of cropped it out to where you can definitely pick up when those animals are toed out quite easily by having those front cameras. We just used, like I said, we used the Zenpro sow chute, and we also used their scoring system for a couple of the traits. And while we had some that were lowly heritable, with the heel toe crack, the white line crack, we were really quite surprised by seeing the hill overgrowth and erosion having a heritability of 0.3. So actually it's one of those where the genetic companies, if you spend the time to come in and lift them or look at them when they're in the fairing crate, with that kind of a heritability, that is one you can make good progress on. We also went and when the gilts moved from gilt development out into the gestation between the stalls and the pens. So this would be their scores for front pastern angles and rear pastern angles moving out of development. 30 days into gestation, we're actually starting to get a little bit of difference on the rear pasterns for the feet and leg angles. And then as we get into mid and late gestation, you actually wind up getting both feet and leg, or both front and rear pastern angles being significantly different between the sows that were in group sow housing and the sows that were in stalls. And then once they come out of weaning, being in that environment, we're kind of back to not significant at that point. So it's actually quite interesting to see how some of these traits would come in and out, to me, depending as much on exercise and flooring, and actually move back quite quickly. If we want to go kind of over time, again, on difference in pens and stalls, you do see a significant difference for unfavorable, for lameness scores in pens versus stalls. And then once they go through lactation together, they tend to actually come back out and be, most of the time, similar. We did have 1 point well out here at a weaning and parity too, where it did flip. But we see a significant change right off the bat when they go into pen gestation, and then we're actually able to correct it with a little bit of different flooring type and the different production type in fairwing. White line cracks are looking to be about the same. They'll do take a little bit longer to come on. So you come out into late gestation, first gestation, before you see the difference. They're still significant. You still see those same cracks essentially at weaning. And then you do tend to pick up a little bit more, but it's consistent. Pens, we're seeing significantly worse feet and leg scores than we were of the gilts that were in stalls. If we want to look at some of the changes in time, so not with the pens and stalls, but just over time, you do see that sows, you have a little bit of fluctuation with their gestational stage, but just generally over time, you see these the angles getting essentially more flex to them, if you will, and the pasturing angles changing as well over time. So when we're selecting these gilts out at 200 days or so, or this would be 112, there is significant change numerically. Now, how much a few degrees biologically means on average, that's still debatable. But there is a significant change from where those gilts start at to where they end up at over time. And we do, obviously, you're going to lose some of these poorer structured ones early. So that's part of why we're seeing what we're seeing there. So some of the associations between conformation and longevity. So measurements and development at the body depth, flank, height at shoulder, and height at flank are linearly associated with longevity. So a little bit of bigger, broodier animal tended to be the animals that work better for longevity. And then out in gestation, some of those measurements are their first gestation. So after you selected them, after you bred them, you've had a little bit of fallouts. So you start getting the depth at the shoulder, so kind of how well those animals might have adjusted out in farrowing or out in gestation. Toe in and toe out on the rear leg, so as they continue development, they get a little bit more weight going towards the rear. Heel sow cracks and total lesions are associated with longevity as well. And then a little bit more complex models with the knee and pasturing angles becoming significant if you look at some quadratic association. And then your heel sow cracks and total lesions associated with longevity. So it makes sense. It tells the story, but we just haven't had a lot of side-by-side comparisons, especially when we really get down to the actual angle, like objective angle of the animals instead of subjective scores on a scale of 1 to 9, 1 to 5, or wherever people really want to look at them at. So conformation definitely continues to change over a sow's lifetime. You do get that cyclical pattern with some of the gestation stages as well. So some of these changes might actually warrant some consideration when you're selecting. I know we always tell selectors we want a little bit of flex to their pasturings. If we know those animals keep progressing, how much flex or where does too much flex become a bad issue, knowing that they're going to continue to break down on their pasturings over time, especially when they're heavy bred. So that's one of those like, Tim, I'm not going to give you the answer, but I'm going to throw the question out and let you ponder on that as well as we try to decide where that goes. Our tall, narrow gilts, and especially those with buck knees, or even on the opposite side, very soft knees, should not be selected. We'll say that. And then the rear foot directional position, so toe it in, toe it out on the rear legs is a very key one for us, and those total lesions definitely become more significant over time. Effects of pens versus stalls. So for us in our study, and granted these were only in their first gestation, that's the only space we had allowed that we could do that. We didn't have enough pen space to take it out to further studies. But we did see those in pens have straighter pastern angles, steeper rope, more toed out on the front feet, and definitely more severe lesion scores. It was also interesting to see that those conformation changes were quick to come on when we moved them out of gilt development and put them into the pens versus stalls, and then actually how quickly that they would dissipate after you put them into farrowing. So is there something about, for us, our cast iron floors and farrowing that helps mediate some of the things that we might have been seeing with the concrete slats and concrete pins that we have in gestation? So one of the different things we also pulled out, because we had it with the cameras, we could see that the toe length seemed to be cyclical on the gilts. Initially, we were only measuring total length, and it was off of cameras. And so we could see when they were coming out of weaning, those gilts had longer toes, and by mid-gestation, their toes were shorter than where they were in weaning. And then we would continue to see the cyclical pattern. So I was able to go back and get iCook approval. So we would score these lines on the gilts with a wood burning tool on the nail. So that way we could come in and measure from the white line down to that mark, and we'd have the above. So when we come back, we could catch growth. And then we know from there below, we'd be able to pick up the wear on those toes. So the story definitely still stayed the same. And I will also throw out a caveat: if anybody wants to do this, it takes a lot of time, and you do smell pretty bad at the end of it with everything. But you want to go out a centimeter before you score. If you try to score any higher, that nail is really thin, and you can burn through that really quickly. So this 10 millimeter mark is probably as close to the white line as you want to get. That'll get you about 2 months of growth on a gilt before it's going to fall off at the end, and you won't be able to measure that. So if we look at total length, and we were seeing that we start off the gilts, and they would be a definite upward cycle to coming out of weaning, with the rear toes being longer than the front toes. But then we were seeing that dip. So there was a slowing in growth and an increase in wear when they were coming out of farrowing for those first 57 days in gestation. And then you would see it pick up every cycle. So for those, we do have several companies that are using the Zen Pro chute, and you're lifting sows and you're trimming toes. Know what your patterns are on your gilts and your sows and their toe growth, knowing where they're going to be the longest and kind of where they're going to wear off a little bit. It might save you some time on which ones you need to trim if they're marginal. They're just coming out of farrowing, knowing that they're going to wear down a little bit before you come back out. But something that was definitely interesting, also those rear toes always seem to be longer. Those front toes, with the way they tend to lay down, they would tend to rub off the tips more so than the rear. So that was keeping the front toes shorter than the rear toes. All of this was insanely human capital expensive. It took a lot of time. I'd hate to count the hours and undergrad hours to go back through the videos, to pull the angles, to pull the measurements, and to take these things. So what we wanted to do, so we had these sows, we have the ground truths for where their angles are at. We needed to go to this next step of being able to automatically process the images out. And so what we did, working with engineers, we looked at some different methods to essentially say, if it's kind of white or pink in the image, that was going to be considered the pig. And essentially, if it's the other colors, it's going to be the background noise. So when you have the pre-processed image with all the panel and everything in the background, all the feeders and everything, after the processing, because we do have those panels there, you can obviously still pick up the panels, but you're going to be able to come back and use this to automatically and easier use the computer vision technologies to pull out what is a front pasturing angle, what is a rear pasturing angle, and those things. So it's one more step in the process to make automated measurements, because we do not have the time, even on the research side, to keep this stuff going much longer, much less a commercial farm. Moving into another study, this was a Port Board funded and FR funded project. It was using maternal females, and they do a rotation back and forth every year between Landrace and York. These were group house replacement females in pens of 10 to 16 animals per pen. There were roughly 75 gilts each week, and these were captured at their 20th week of age. So we had them under cameras at that point. So we had a total of 2,300 gilts, and then we actually had just over 1,000 of them. Their selector did not keep back, retained for breeding purposes. So if we kind of look at it, they keep back a large percentage, but as I'll tell you in a kind of my concluding study, they keep a lot of gilts around. They don't farrow a lot because they have a lot of other reproductive trials going on, so they overbreed and to follow animals out before they pull animals out and study them before they go all the way completely to farrowing. And then we used the RStudio and ASRimmel to analyze some of the data. So we utilized our the new track system. So that was it's a computer vision technology that's developed at the University of Nebraska with IP rights. And what that uses is we have these 2D commercial security cameras. They withstand harsh environments, and we all know pig barns are very harsh environments. These are the hurricane proof. They go down to minus 40 and up to like 50 degrees Celsius, so they can maintain a wide range. They're watertight for the most part. I wouldn't tell you to hold a pressure washer on them, but they have been hit with a pressure washer in a glance. And other than kind of cleaning off the fly specks and the water spots, you can keep going with them. While these do have IR lights, we actually added additional IR lights to catch the edges of the pens, so we can actually record 24/7. And then while you can capture at 30 frames per second, at 4K resolution, we did 5 frames per second at 2K. Otherwise, it just becomes too data intense for us to process on the backside. So on these 2,300 gilts, data was collected for 7 consecutive days, 24 hours a day. That video feed was pushed out to a Dell Alienware GPU with a graphics processing system to process the videos. The new track uses a Bayesian multi-object detection method to track individual pigs in the pen. And we can identify the location of the different points, so the head, the ears, and the tail head, the XY coordinates of those locations in the pens at all time, so up to 5 frames per second if you really want to get that detailed. And then it detects, so we can tell you the distance walked, the average speed in meters per second, the angles rotated, time standing, sitting. It says eating, but I'm going to say that's at feeder. We also could do at water, you can do any part, and can determine the difference between lying sternally and lying laterally. So we can tell you up to 5 frames per second what these animals are doing at that level. And then with all those different coordinates, we had the potential to add in detection for aggression with some of the XY coordinates and also some social preferences. So with the deep learning, with the multi-object detection, essentially it's able to discriminate between the left ear, right ear, as well as the stout. I need to add that on. Point over the shoulder and a point up on the rump. So we always know the orientation of these animals. So when we go back and want to plot 2 pigs, with time we'll be able to tell you who's head to head, who might be kind of side by side fighting. And then if you think of tail biting, you know, whose head is always at the tail of another pig that is the victim. And then it's able to join those instances as a part of a pig to say what is a whole pig. We also, because pigs love to pile, especially when we did this in nursery pigs, not so much in finishers, but pigs love to pile. So you need to have a way for the system to re-identify when pigs are on top of each other when they come out of those scrums. So this is we use these tags. So this was, like I said, we had up to 16 pigs in a pen. So these are just alphanumeric unique tags within a pen. And because we were having grad students still go back and check for the accuracy, having the extra color also helps the grad students determine whether or not the system was tracking it accurately or not. And I will say, so these are just an all-flex tag. They're non-RFID, and as you can see, they're non-barcoded. The system doesn't even need to see the full tag for it to be able to recognize which tag it is after it's learned them. And so we have added in more tags, but you need to retrain in the environment all the time. So it's not to the point where we can just run your sequential numbers in a sow barn and pick up those. But I will say probably with time, we can probably get to that point. So you kind of see a little bit of it in action, how it has the animals identified and tracked. So it kind of has the ID of the animal over the top. So if you wanted to pause it to check it against the ear tag, you could. It also tells you what it's classifying the animal as, so it's calling it standing. The N is for not at feeder. A little bit before or later, it was kind of up here. This was the first time that we were testing out the 16 tags, so we actually took 2 pins and mixed them. This little clip is about all of this I could show you because we did get into some fighting, which is actually going to be used for some other stuff. You can see it switches over to calling that animal at the eating. So it's not just if it's at that location, it also is looking at its head orientation as well. So it's a little bit more precise than just the general location of what it's classifying the animal. And if you're kind of watching down here, these were the animals, the ear tags. You were seeing these numbers move, so it's keeping up with the distance that animal was tracked, and the angles, the rotations. And then if you wanted to figure out where that animal was down here on the bottom, on the output, you could find the 2 dots that correlated and then go find it up at top. So it's another way for you to try to identify that animal. Some of the things that we've been able to kind of pull out of that. And so this was some of the data from US Mark again. And so we actually had an animal that was removed for lameness. And when you actually come back and look at the data and you were looking at its average speed when it was walking, it was substantially slower moving than the rest of the pigs in the pen. We also had instances of when they picked up when pigs are sick, and also then you get it where pigs died as well. They don't move very much at that time point either. But you can see also one thing I want to point out and also caution everybody when we're looking at precision livestock technology is the data is extremely, extremely dirty. Pigs don't always do the same thing they did yesterday, and you can kind of see how the animals kind of bounced up and down as they moved in and out of these pens, or in that same pen from day to day. But there are some things you can definitely pick up. So there we had an animal for some reason drop way down here. You get pen effects of you're not sure what's going on. We know from other trials that when we come in and we pull those animals out and we weigh them, not only does it make their activity that day go up, but then they have a drop in activity the next day. So I would caution everybody that's doing a lot of weigh and feed trials. You might want to minimize the number of times you're weighing those animals that you don't need it, because every time you do, you're changing the activity of those animals, and it might be why some of that data doesn't correlate to some of our finisher data in the end. So because everything was pedigreed out at US Mark, we're able to go back and pull and look at the heritabilities, look at the genetic variation. We were a little bit surprised to see the heritabilities be where they were. Everything seemed to be moderately heritable. Line was the lowest down to 0.21, and for that study we combined them. But after some results we're seeing here this past week, we're going to go back out and split that out because we're seeing a definite difference in how animals behave, whether they like to lie more laterally or sternally. So where this just kind of as a reminder, so if our reproductive traits are literally heritable at 0.1, we've seen all the data that shows how much genetic selection we can make on those if we want to. We can make a lot of genetic progress on these once we figure out what it all means. So I will caution everybody on that. We still have a lot to learn, but it starts with getting the data and getting accurate measurements, which this does quite well. When we looked at the retention of those gilts, so we had a lot of different fixed and random effects, so we can kind of argue on what we want to classify where. But the angle and the average speed was related to those animals being retained. So if they moved more and they walked quicker, retained, and the animals that spent more time standing were retained. So we can kind of think of that if they weren't painful or they weren't in pain, they could stand up, they could move. They were okay to be kept back. Line was not necessarily a significant. Distance wasn't, but it was in the direction of the animals that moved more were the ones that tended to be retained. I want to caution this. I think we have some intermediate optimals as where we're going to want on some of these. We're not going to want those animals that are so agitated or so hyper, they're always out and they're going really fast. This is kind of a threshold to me of where you need to be to say you're comfortable on feet and legs. And again, without having somebody have to come in and make that selection call. And also, this was done a week in advance of selection. This was in their natural environment. There was nobody coming in and changing their behavior with them walking them into an unknown pen, walking them across a scale, or getting them agitated. This is the animals doing what they normally do. And then, just because you have the data, you want to see where some other things go. And I'll caution everybody, this is very preliminary. This is probably less than 2 weeks old. But we do have the reproduction data on all these females, and this would be parity 1 gestation length, and it's on roughly 480 gilts that did farrow. And so how quickly those animals moved, so the ones that moved quicker tended to have a longer gestation length. Those animals that rotated more tended to have a longer gestation length. I'm not sure I can explain it all. And then also the one that kind of it also made me wonder and made me say we need to go back and look at the heritability difference between lying sternally and laterally, split them apart versus together, is that we see two different trends. The gilts that spent more time in gilt development, so at 140 days of age, the gilts that spent more time lying laterally had a shorter gestation length than the ones that spent more time lying sternally were longer. So are these the animals that are a little more agitated, a little more hyper, a little more on watch? What is it about these animals that's driving some of these other behaviors? So like I said, I'm not going to be able to explain it all. I just thought it was interesting enough and kind of fits the theme of this topic or this conference of some of these behaviors and activities that we're seeing in early life are heritable. And then there also could be one more thing we can add to help predict some of our sow productivity data. And this one here is on number born alive. Again, those animals that spent more time lying laterally had larger litter size, and then it decreased with those that spent more time lying sternally. And this, I could show mirror data to this, or similar data if you look at number wean. Those ones that spent more time lying laterally weaned more pigs, and the ones that were lying sternally weaned less. Part of it is just with what they started, but if we think of maybe some crush loss, some lay-downs, you get the sows that maybe lie laterally, maybe they're just a little more comfortable, maybe they don't get up as much. What is it about these sows that also helps them give you more pigs and then wean off more in the end? So like I said, this is really preliminary, but because I thought it was kind of interesting and we saw some definite trends, I thought it kind of fit this conference, and I wanted to throw it out in front of everybody here today. Some of the other things that we can look at so you can track changes over time, because again, all these points that you're tracking, so the head and the tail, the ears, those things, have XY coordinates. So this is actually in nursery on a on a animal. So the first 2 weeks of its life, it was eating out of actually all 3 holes on the feeder. By the time it got to the last 2 weeks in nursery, it was just down to 1. And then you could tell early in life, it did not have a particular spot it liked to lay down. It kind of moved around quite a bit. But by the time we got to the end of the nursery, it had a very dedicated spot where it liked to lay with its head in this corner and its tail in the other corner. So not sure what that data means, other than it's one more thing we can come to the environment, maybe kind of look at some of the heat stress stuff to tell us how things change over time, some of the differences. And so just kind of the power of some of the computer vision technologies that are coming. We also get into a little bit of where we could do some of the social network analysis. So this is a single pen of pigs. And so this would be the lighter color is actually the closer two pigs are to each other over time in that pen. And the darker, the further apart they tend to be. So this NN animal tended to be really close to a lot of people. And then he kind of had this 1-1 animal that tended to be a little bit further apart. So the question I have, because we haven't gone back to look at the video yet, is one of them a needy social butterfly that needs to be beside the others, or is he the aggressor and is picking on and fighting with everybody? And kind of the opposite question with the one that's further away. So just some interesting caveats of what that data can come when we have the XY coordinates of those. So we're going to go back and look at the distance when we had the tail biting to be able to pick out who's doing that, some of the fighting. And then we also are going to get into the really kind of a nitty-gritty social network of who likes to go to the feeder together. Because one thing about it with these pens, when you have multi-holes, who likes to go beside each other, and then also who likes to sleep next to each other in kind of a buddy system as well. So because we can always track it, the XY coordinates, that's some of the data that we can come back out. Maybe it's going to give us a little bit more of the piece of the pie as to why maybe some sows aren't as stressed as others, maybe others are, and maybe it's just going to be a jumbled mess in the end, but we're not going to know until we roll through the data. But so overall conclusions, body conformation angles, foot lesions, and activity are heritable. They change over time. We definitely have cyclical patterns as far as how those body and conformation traits change. I think technology is definitely going to help us aid in selection or replacement females. And then kind of the last part is these activity traits of gilts in development might be indicators of future reproduction of those females. National Pork Board, especially the Animal Welfare Committee, FR, UNL, and Nebraska taxpayers, I think they're more happy to pay for that right now than the football team. And then we have a lot of people that were helping on all these projects. So with that, I'll answer any questions you might have.
Thanks very much, Benny. First of all, just any questions from the audience? I do have, I'm going to go back to Tim. Yeah.
So Benny, I was curious, if you look at your angles, et cetera, of only those that only made one parity versus those that made only two, versus if that wouldn't be a more powerful way than the average, it includes all the good ones.
Yeah, we need to go back and piece that out so we can take those animals that made it all the way out to parity 4 and compare that more so against the ones that just dropped out. So the more the side-by-side comparison, so just not taking in the changes over time, but the true differences. So we need to do that.
Questions? Benny, when I look at what you're doing and all of the information, it's a huge amount of data. And you're looking at various gathering subsequent data based on some of the images and patterns that you're looking at. So once you get this figured out, once you get the data clean, okay, that you're confident in the data, would this be a candidate for something like machine learning to look for patterns and relationships within one trait to another? Yeah,
so right now, and I didn't mention it earlier, so when you just have the cameras on with the new track, that's about 1 terabyte of data per 12 cameras per week. So that's not something you want to necessarily store long term. That's something you want to get more machine learning on, some of the edge computing to make some of those decisions right there at the farm versus trying to send it out to some big processors and servers that will process it later. So machine learning, it just like how machine learning was able to identify the different parts of the pigs, getting enough of the data and go through machine learning to pull out what means what. So what traits are going to be more beneficial to what we're looking at. And I'll say, so we're starting with, comparing some of these traits with what we know or what we want, with some of the reproduction data. The next thing is to just let the machine learning go on its own to help maybe inform us of what we're not seeing. So the engineers tell us that if we see it, we can train the system to find it. And I think we'll do a very good job at that. But the next question is, I want them to be able to tell me what I'm missing, what I don't know.
And that's what I was getting at, is that there's only so much we can do or imagine, and there may be patterns there that are unimaginable, but that may lead to other information as well.
Yep.
Other questions, comments? We're getting later in the day, so people are getting... Yeah.
This is more in the direction of discussion, I guess. If you have a large commercial farm and you identify the sows that live long, do well, and you genotype them, and then in the pure lines you pick up the genotypes which do well, is that highly similar to what you're doing here?
Yeah, I think it'd be similar. We're trying to identify those that live well with different precursors. So, especially with the new track and identifying the gilt. So the other part of that U.S. mark studies, all those are obviously DNA sampled on that. So we're going to have the genotypes to come back and add on that as well. So, so if we train and figure out the activity traits, what they mean, then if there's any genetic markers to it, so then you could do your GBVs for some of these indicator traits as well.
Because I think that I'm in a similar situation as you. We do lots of this type of stuff. It's humongous the amount of data. And then you're digging deeper and deeper and deeper. In the end, what do we want? Sows that live nicely. Well, collect that data, do the genotyping, and you're done. So should we invest a lot of money in this type of technology or not?
I think we do, to help us understand those animals that live and what it is about that. I don't think we're going to need it forever, but I think to help us learn intermediate, I think we will. But in the case of maybe gilt selection and running gilts under a camera right ahead of commercial guys doing that, making selection, I think that would go a long way and be a heck of a lot better than those selectors that go, I need a load out. Let's see, I need 180 gilts. If I open these first 6 pens, I get 180 gilts. I won't even go to the end. So I actually have it where it'll help us select those.
So in your selection, or in your work that you've done so far, have you had groups that have had disease challenges? Were you able to pick up, the ones that were more severely affected, or have you had that opportunity?
So there are other projects ongoing with this technology, or with the new track as well. So we've done some LPS projects. You can definitely pick out which animals get sick. You can look at, to me, LPS is so hard on the animal, it's really easy to see that. But we're also, when we mix pigs in a pen and had it with trained observers and not, it was more able to identify which pigs were sick and also stayed sick longer as they came out of it than trainers. And we've also looked at the data, and it makes sense, but the animals that are more active have less average daily gain, and it matches right up with the breeding values of their sires as well.
All right, so we're into our break time, so I think I'll call it that. Thank you very much, Benny, for that presentation.